measurements, and unit. A must-watch video. Subscribe, like and share. Measurement is a very important aspect of physics and other sciences. No fact in science is accepted, no law is established, unless it can be exactly measured and quantified. As physics is based on exact measurements, every such measurements requires two things: first, a number or quantity. Secondly, a unit, example 10 meters as the length of a room. However, measurement are not perfectly precise. We usually note the reading accuracy of the measuring instrument to avoid parallax errors and other errors when measuring. In a giving result, it is good to practice precision or estimated uncertainty in measurement. For example, we can write the length of a wire as 51.3 plus or minus 0.1, where 0.1 centimeters represent the estimated uncertainties in measurement. This means the length is probably between 51.2 and 51.4 centimeters. The 0.01 centimeters indicate the precision with which a particular instrument has been made. A unit or standard of measurement should be such that 1. It must be possible to define it unambiguously, that is, without uncertainty. 2. It is easily reproducible. 3. It does not vary with time and place. 4. It should be possible to multiply or divide each one of the standard. There are different instruments used by physicists for measuring physical quantities and different units in which these quantities are expressed. There are also relationships between quantities and some uncertainties associated with the measuring devices. The system International Units is the most important system today. It is used to be called the MKS, meter kilogram second, system. The SI unit is based on meter as the unit of length, the kilogram as the unit of mass, the second as the unit of time, ampere as the unit of electric current, and Kelvin as the unit of temperature. Another metric system is the CGS system, in which the centimeter, gram and second are the standard units of length, mass, and time. SI units are the principal system of units used in scientific work today. The three most important basic quantities in physics are length, mass, and time. Length may be defined as the extent of space or distance extended. Mass is commonly defined as the quantity of matter or material substance. Time is defined as that in which events are distinguishable with reference to before or after. Note: length, mass, and time are the three of the most fundamental quantities. Let us take a glance on fundamental quantities and units. Fundamental quantities are the basic quantities that are independent of others and cannot be defined in terms of other quantities or derived from them. They are the basic quantities upon which most quantities depend, though not all. Fundamental units are the basic units upon which other units depend on. They are the units of fundamental quantities. Examples of fundamental quantities and their units: length, which its unit is meter; mass, which its unit is kilogram; and time, which its unit is seconds, and many more like. Temperature in Kelvin and electric current in ampere. Derived quantities are those obtained from the combination of fundamental quantities, they are thus dependent on the fundamental quantities. Derived units are those units obtained from the combination of the fundamental units and are dependent on the fundamental units. Examples of derived quantities and their units. Units used in industries and business are differ from those used in laboratory, because in these areas the quantities involved are very large. For example, power measured in watts in the laboratory may be measured in horsepower in industry. 1 horsepower, 1 HP, equals 0.746 kilowatts. In oil industries, the barrel is used as a unit of measurement. 1 barrel of oil is equal to between 120 and 159 liters. Oil prices are usually quoted in dollars per barrel. An hectare is a unit of measuring the area of land. An hectare, h, equals 10,000 square meters. The volume of a liquid can be measured with a measuring cylinder, a pipette, or a burette. The correct liquid level is read at the curved meniscus. Mass is defined as the quantity of matter or stuff contained in a body. The mass of a body is measured with a balance, of which there are various types of balance: a beam balance, chemical balance, and a lever balance. Precautions taken when using a beam balance. For accurate result, precautions should be observed. 1. Forceps are used and not human hands for picking up the masses. 2. The object are wiped dry before being placed on the scale pan. 3. Hot objects are allowed to cool before weighing. While weight is the force of or pull the earth exerts on a body towards the center of the earth. The weight of an object is found using a spring balance, which follows the principle of Hooke's law. Precautions taken when using a spring balance. For accurate results, precautions should observe. 1. The eye is placed horizontally with the pointer when taking reading to avoid errors due to parallax. 2. The spring is stretched lightly with hand and released before taking readings. This is to remove possible kinks in the spring. 3. The balance is held still and vertically while taking the reading, or better with a firm support or hook. We define time as that in which events are distinguishable with reference to before or after. The most natural time unit is the solar day, which is manifested by passing of day and night. It takes the Earth 1 solar day to complete 1 revolution about its axis. For astronomical purposes, a different time scale known as sidereal time is used. This is the time interval between 2 successive passage of a star over the meridian. At the present period, the essential mechanisms of the devices are used for marking the passage of time are masses mounted or suspended that when set in motion under the influence of forces, they repeat with great regularity fixed circles of their motion. The pendulum of a clock and the balance wheel of a watch are 2 of such mechanisms. Hence nowadays we measure and indicate time with clocks. In the laboratory, time is measured with a stopwatch or a stop clock. The stopwatch enables us to measure small intervals of time. The unit of time is second with its multiple unit. 60 seconds equals 1 minute. 60 minute equals 1 hour. 24 hours equals 1 day. Note, the most accurate clocks of all are the quartz crystal clock and the atomic clock. Thanks for watching. Don't forget to like, subscribe, and share. You can also make a comment.